Hello everyone, I hope everyone is fine. This is an interesting problem that initially I thought is an ordinary problem and I wanted to post it without explaining the solution. But after I solved it myself, it turned out to be an interesting one. And in fact, after I looked at my own solution from my high school time, it turned out that I missed two of the answers. So this has multiple answers, and if you like to solve it yourself, please pause the video now, and I'll come back in a few seconds to solve it for you. So like always in problems like this, it's better if we draw the xy axis and see visually where the points are and see if we can find a clue to solve this. So this is the origin at 0, 0, and a, its x value is 6, so 1, 2, 3, 4, 5, 6, and its y value is 0, so this is a. It is a right angle triangle, so there are multiple ways to build this right angle triangle on OA. So the obvious way is to assume that OA is one of the sides of the right angle, and therefore I can say that a triangle can be like this. It can be the third vertex can be this point, or it can be this point, or similarly it can be this point or this point. So let's assume that the third vertex is this point. Let's call it B, and if I make the triangle, it will look like OAB. And now we know that since this angle is 90 degrees, then AB can be the height of the triangle and OA can be the base. And therefore, area, let's call it S, will be 1/2 of OA times AB. And we know that OA is 6, so S is 1/2 times 6 times AB. And we also know that S, which is the area, is 6. So AB will be 2. And therefore, the third vertex, one of them, is B equal to x of B is 6 and y of B is 2. Or similarly, let's call this B1. B2 can be 6 and minus 2. Or B3, which is the x value is 0 and minus 2, or B4, which is 0 and 2. So we already found 4 solutions for this, and these are the obvious solutions. So the triangles will be like this, or this, or this, right? However, we assumed at the beginning that OA is one of the sides of the right angle of this triangle. What if it is the third side, which is not one of the sides of the right angle? So if I draw the xy axis again, a third or a fifth option, 4, 5, 6, is if we have O and we have A, but the right angle is somewhere up here. So this is the right angle. Or alternatively, it can be down here, right? So in that case, the area, let's call this point, for example, C, and this C prime, and let's consider the triangle OAC for now. So if I call this length A and this length B, I can write that S equals to 1/2 A times B, because this is a right angle and A can be the base and B can be the height of the triangle. So 1/2 of A times B is equal to 6, and therefore A times B is 12. On the other hand, from the Pythagorean theorem, we know that, so this is equation 1, and then we know that A squared plus B squared is equal to OA squared, which is, we know OA is 6, so this is 36. And we have another equation, a squared plus b squared is equal to 36. So one way to solve this problem, or to solve this equation, is to find a from the first equation and then replace it into the second equation and then find b from that. But I find it easier if I solve it this way. So our first equation is the multiplication of two numbers, and the second equation is the sum of the squared of those two numbers. So if I find 2 times AB, 2AB will be 24, and a squared plus b squared is 36. So if I add these two together, I will have a squared plus 2ab plus b squared is equal to 60. And here we know that the left hand side is a plus b squared, and that is 60. And from there we will get a plus b equals to plus minus square root of 60. But given that a and b are the length of two line segments, they are positive numbers, therefore the negative answer is not acceptable, and a plus b will be square root of 60. Now, we know the sum of two numbers, and we know the multiplication or the product of those two numbers. Therefore, we can construct a second order equation whose roots are those two numbers. And we know that if we have the second equation, a x squared plus b x plus c equals to 0, and if we divide the two sides by a, we will have x squared minus b over a x plus c over a equals to 0. And from quadratic equations, we know that this is the product of the roots, and this is the sum of the roots. Therefore, if a and b are the roots of a quadratic equation, I can write that equation to be x squared minus square root 60x plus 12 equals to 0. Now, from here, we form the delta of this, and that is b squared, which is 60, minus 4 times a, which is 1, times c, which is 12. This is 60 minus 48, which is 12. And therefore, x will be minus b, which is root 60, plus or minus square root of delta, which is 12, divided by 2a, which is 2. We can simplify this as square root of 60 is the square root of 4 times 15, plus minus square root of 12 is square root of 4 times 3, divided by 2. And we know that this is 2 square root of 15 plus minus 2 square root of 3 divided by 2. So x1, which is a, for example, is square root of 15 plus square root of 3, and x2, which is b, will be square root of 15 minus square root of 3. Or vice versa. You can also say b is square root of 15 plus 3, and a is square root of 15 minus 3. And just by looking at this, we can also write this square root of 3 times square root of 5 plus 1, and this square root of 3 times square root of 5 minus 1. So we found a and b. Let's go back and look at our equations. We have found a and we have found b, but we need to find the coordinates of the point C and point C prime. If we know, or if we assume that the coordinates of C are x and y, then we know that the distance from the origin to a point at x and y is equal to square root of x squared plus y squared. So I can write a is equal to square root of x squared plus y squared. And x and y are the coordinates of the third vertex of the triangle, which we call it C. We also know that the distance between 2 points on xy axis is the square root of the difference between x coordinates squared plus the difference between y coordinates squared. So we have a at 6 and 0, and a was at 6 and 0. So point B or length B will be square root of 6 minus x squared plus y squared, right? So from here we will get a squared is x squared plus y squared, and b squared is 6 minus x squared plus y squared. And if I subtract these two from each other, we will get a squared minus b squared will be x squared minus 6 minus x squared, and y squareds will cancel from each other. Now we know what a is and we know what b is, so we can solve this quadratic equation this time and find x. So let's form a squared minus b squared. So a squared minus b squared is, a squared is 3, 5 plus 1 plus 2 root 5, and b squared again is 3, so we can factor out the 3 minus 5 minus 1 plus 2 root 5. So these will cancel and we will get, this is 4 square root of 5, 12 square root of 5 is equal to x squared minus 36 minus 12x plus x squared. So then this x squared and this x squared will cancel and we will get 12 root 5 equals to minus 36 plus 12x, and therefore 12x will be 36 plus 12 root 5, and x will be 3 plus root 5. Now we also know that a squared is equal to x squared plus y squared. So a squared is 3 times 5 plus 1 plus 2 root 5 will be equal to x squared, which is 9 plus 5 plus 6 root 5 plus y squared. So this is 6, and the left hand side will be 18 plus 6 root 5 is 14 plus 6 root 5 plus y squared. So these two will cancel and y squared will be 4, and therefore y will be plus or minus 2. So the 2 points that we had, these 2 points, c, x and y, and c prime, let's say x prime and y prime, are going to be, c will be 3 plus root 5 and 2. So this is vertex number 5. Vertex number 6 will be c 3 plus root 5 and minus 2. And then there seems to be 2 other vertices too that I missed. So I can also form this triangle like this. So there is a point D and D prime as well. So let's see where we missed. Oh, okay. So if you remember, I said before that a can be square root of 3 times square root of 5 minus 1, and b can be square root of 3 times square root of 5 plus 1. So if we do that, I bet we will get the answers that we're looking for. So this time, let's say a is root 3 times root 5 minus 1, and b is root 3 times square root of 5 plus 1. And we can do the same as last time. So this time again, a squared minus b squared will be x squared minus 6 minus x squared. So this time a squared minus b squared will be 3 times 5 plus 1 minus 2 square root of 5 minus 5 minus 1 minus 2 square root of 5. So this time it will be this and this will cancel out. We will have minus 4 square root of 5, so minus 12 square root of 5 is going to be equal to 36 minus 36 plus 12x minus 36 plus 12x, and therefore this time x will be 36 minus 12 square root of 5, which is 3 minus root 5. And 3 minus root 5, if we want to find it on the xy axis, just for sanity check, square root of 5 is something between 2 and 3. So oh, so I actually made a mistake in showing c and c prime. Actually, c and c prime are these 2 points. Let me clean up here. So this was b. So this is c, this is c prime. And the 2 points that we found, d and d prime, are here because c and c prime, the x of c and c prime is larger than 3. So it has to be somewhere here. And for d and d prime, it's going to be something smaller than 3. So it's probably this point. So if x is this number, we know that a is x squared plus y squared again. So a squared is 3 times 5 minus 2 square root of 5 plus 1 is x squared, which is 9 plus 5 minus 6 square root of 5 plus y squared. And from here we get actually this is 6, 18 minus 6 square root of 5 is 14 minus 6 square root of 5 plus y squared. So this again will cancel with this, and y of these two numbers is again plus minus 2. So point D is 3 minus root 5 and positive 2, and point D prime is 3 minus root 5 and negative 2. So in contrast to what I taught, there are actually 8 points that can be the third vertex of this triangle, not 6 points. And this way we solve the problem. If you like this problem, please consider subscribing to the channel and giving it a thumbs up and sharing it with others who might be interested. Thank you.